All right, so let's go ahead and solve this equation here. First of all, we want to simplify each side of the equal sign separately. So here's our equal sign in the middle. So I'm going to simplify the left side and the right side separately before I do anything else. So on the left side, I can simplify by just distributing that -4 or multiplying both of these things by -4. So -4 times 3x, that's going to give me -12x. And -4 times -5 is going to give me +20. So that's the left side. Then I've got an equal sign in the middle. Now I need to simplify the right side. So first of all, on the right side, I do have parentheses, but the way this is written, I have 3 minus this expression, 3 minus 8x plus 7. So I'm not distributing the 3. What I'm doing is I'm subtracting. So I've got the 3 in the front, and then I'm subtracting everything in the parentheses. So one way to think about it is we're subtracting 8x, and we're subtracting 7. Another way to think about it, since there is not a number in front of the parentheses, it's like there's a 1. So I'm distributing the -1, since it's a minus, I'm distributing a -1 to both of these. So I still have the 3 in front, and then I'm distributing -1, so -8x and -7. Now, since these are on the same side of the equal sign, I'm just combining like terms. We're just simplifying that side. So combining like terms, 3 and -7 would combine to -4. So on the right side, I end up with -4 minus 8x. Let me rewrite the other side. So I've got my equal sign, and my left sign was -12x plus 20. Okay. So that's the first step. We always want to simplify each side of the equal sign separately. Now I want to try to isolate the variable. As we can see, after we simplify and get rid of parentheses, we just have x to the first power. So I know this is a linear equation, but I do have x's on both sides of the equal sign. So when you have x's on both sides of the equal sign, in order to isolate the x, we need to get all the x's on one side, all the variables on one side, and all the numbers on the other. It doesn't matter which side we choose for which. So I'm just going to get all the x's on the left and all the numbers on the right. And so the way we do that is we use inverse operations. And also remember, on an equation, whatever we do to one side, we got to do to the other. So on the left side, I'm only going to keep the x's. So I'm going to keep the -12x where it is, which means I want to get rid of +20. So the inverse operation of +20 is -20. And since I subtracted 20 on the left side, I also have to subtract 20 from the right side. So always do the same operation to both sides. So on the left, the +20 and the -20 add up to 0. So I don't have to write that anymore. So all that's left on that side right now is -12x. I still got the equal sign. On the right side, pay attention to which ones are like terms. The -20 doesn't have an x, so it gets combined with the -4. So a -4 and a -20 gives us a -24. So we have -24 minus 8x. I cannot combine anything with the x, or the 8x, because that has an x with it, and the other ones don't. So continuing, we know we only want numbers on the right side. So on the right side, that means if I only want numbers, I got to get rid of the -8x. The inverse operation of -8x is +8x. So I'm going to add 8x to both sides. So now on the left, -12x plus 8x gives me -4x equals, on the right side, the -8x and the +8x add up to 0, and we're just left with -24. And then lastly, I still don't have the x by itself. So I do now have all the variables on the left and all the numbers on the right. Now I want to get the x by itself. Right now I have -4 times x. And so to get rid of that -4, the inverse operation of multiplying by -4 would be to divide by -4. So I'm going to divide both sides by -4. When I do that, the reason we divide by -4 is because -4 divided by -4 is 1. And so then we're technically left with 1x, but we don't really have to write the 1 when our coefficient is 1. So I just have an x on the left, and then on the other side of the equal sign, -24 divided by -4, a negative divided by a negative, this would become +6. Once the x is by itself, that is our solution, x equals 6. So what it means to be a solution is that number makes the equation true. So if I were to plug that number in to the equation for both x's, so here and here, and simplify each side, it should make both sides equal. It should make the equation true. So you can always check your work by plugging in the number. So you should do that if you're doing an assessment, but we're not going to right now, just mostly for space and time. Okay. So I know we just did one example that was pretty quick, but we're going to do a few practice problems before we do the next type of example. If you look at the next problem, it has some fractions. So before we do ones with fractions, I just want to make sure we can do regular old linear equations. All right. So we're gonna, like I said, I'm gonna do a practice problem. I'm gonna put a practice problem up. With the practice problem, remember, this doesn't need to go on your note sheet or in your notes, but it can if you want it to, or it can just be on any paper. Now, this is a very basic linear equation. It doesn't even have variables on both sides. So I'm guessing everyone should be able to solve this. So go ahead and just solve this on your paper or scrap paper or whatever, and then type me your answer. Let's see what you get. Okay. I think I got most people's answers. All right, so this is, it still is a linear equation, and we're still trying to isolate the x, but it's definitely more simple because there's only an x on one side of the equal sign, and I don't have to do any simplifying beforehand. So the correct answer, which I think everybody who answered got x equals 6. That is correct. So the way we would do this, the way we would try to isolate the x is, since this is the only x, I'm going to keep it where it is, and I'm going to get rid of the -8, so add 8 to both sides. And so we get 4x equals, what is this, 24? And then divide by 4, and we get x equals 6. Okay, good. So if you could do a problem like this, this would be like a minimally proficient level, because you can still solve an equation, but it's at the most basic level, or the most basic type. But of course, let's try another practice problem. So good job with that one. All right, here's the next practice problem. Let's see how this one looks. So still practice. You do not have to write this in your notes. You can write it on whatever you want. So -2 times the quantity 3x minus 5 equals 5 times 2x plus 8. So -2, and then in parentheses 3x minus 5 equals 5, then in parentheses 2x plus 8. All right, so solve this one. This one you are going to have an x on both sides of the equal sign. So you're going to have to get the x's on one side and the numbers on the other. Your answer on this one, I believe, is a fraction. I don't think it's a whole number. So don't worry if you get a fraction. Just type it to me in the chat. All right, take another maybe minute or so to try this. Okay. So, I am seeing a lot of people on the right track. But I am seeing some sign errors. That's the most common error. So the correct answer, some of you wrote it as 30 over negative 16. That's correct. Some of you reduced it to negative 15 over 8. That's also correct. I don't think anyone put it as a decimal, though if you did, that'd be fine. But I did see a few people have the right numbers, but didn't have the right sign. So that's just something to watch out for. So let's go through this. I'll try to go fairly quickly because I think most of you have are on the right track, but just maybe had a small error. So on the left side, so we want to simplify the left side and the right side separately. On the left side, I would distribute the -2, and that would give me a -6x and a plus 10. Then we got our equal sign, and on the right, we would have 10x plus 40. We would distribute the 5. Okay, then since there are variables on both sides of the equal sign, I want to get the x's on one side and the numbers on the other. So to get the x's, I'll get the x's on the left. If I only want x's on the left, I would subtract 10 from both sides. And that will get rid of the plus 10 on the left, and we just be left with -6x. On the right, I can combine the 40 and the -10 because those don't have variables. So then I'd have 10x plus 30. Now on the right side, I only want numbers. So I'm going to keep the 30 where it is, but I'm going to get rid of the 10x. So to do that, I'm going to subtract 10x. So when I subtract 10x from both sides, now on the left, I would have -16x. I have a -6x and a -10x. And then on the right, since those add up to 0, I would just be left with 30. Okay. Now remember, our goal is to isolate the x. So after this, to get the x by itself, I would need to divide both sides by -16. And that would allow those x's to divide out, and we'd have x equals 30 over -16. Okay, so I saw a couple answers like that. And most of us though reduced this. If we have a positive 30 divided by a -16, we know that that would be a negative number. So usually when we have a fraction, we would write the negative in the front, although it's not incorrect if you write it like this. And then the 30 over 16 can reduce to 15 over 8. They're just both divisible by 2. So when you're typing it in to the chat, you just have to use the division or the slash like this, -15 over 8. And if you do get a fraction answer, it's best to leave it as a fraction rather than getting a decimal. You totally could get a decimal, which is like -1.875 if anyone did divide. But there are cases where we wouldn't want to divide because we'd have a non-exact answer. Fractions are better because they're always exact. Okay. I feel like we got that down. I think the errors I saw on that one were just more simple errors or like forgetting the signs. So just always watch out for those signs. So we are going to go back to the notes. So we just did a couple of practice problems. And now we're going to do another example in the notes. Okay. So get your notebook that you're taking notes in, or your note sheet if you printed it. And here is our second example. So everyone write down example 2 so we have it in our notes. 3x plus 6 over 10 minus 1/2 x equals 2/5 x plus 33/5. 3x plus 6 over 10 minus 1/2 x equals 2/5 x plus 33/5. Okay, now the difference here is that this equation has fractions in it. So most of my students do not like dealing with fractions. If you don't like dealing with fractions, don't just skip the problem. I know that some of you just do that when you see a fraction, but let's not do that. Instead, we'll have a way to be able to get rid of fractions in cases like this. Okay, so before we solve that problem, let's write down what we're going to do. So to solve an equation with fractions, so if you have the note sheet, I'm writing off to the side over here. To solve an equation with fractions, we're going to multiply everything by the LCD to get rid of fractions. To solve equations with fractions, multiply everything by the LCD to get rid of fractions. All right, so make sure you make a note of this in wherever you're writing your notes. To solve equations with fractions, multiply everything by the LCD to get rid of fractions. In case you don't remember what LCD stands for, it stands for least common denominator. To solve equations with fractions, multiply everything by the LCD to get rid of fractions, and LCD is least common denominator. So let's do example 2. All right, so here's our example we are looking at. The denominators we have in this problem are 10, 2, 5, and 5. Some of you might be able to look at those numbers and just figure out in your head, what the common denominator is going to be. But we're going to go through the process of finding the common denominator because we'll need to know the steps for when our common denominators aren't necessarily numbers, when they might have variables. Now, one thing with a common denominator is you can always multiply the denominators to get a common denominator. So technically you could do 10 times 2 times 5 times 5, and this would be a common denominator. That's a pretty big number. This is 500. That is a common denominator, but it's definitely not the least common denominator. So even though you can do that, we probably don't want to because the numbers are usually pretty big. All right, so let's figure out how to find the common denominator. The first thing we want to do if we're trying to find the lowest common denominator is we want to factor the denominators. In this case, when our denominators are numbers, when we say factor, that means we want to break it into prime factors or prime numbers. The only one of these that's not already prime, 2 and 5 are already prime, 10 is not prime. So I'm going to break 10 down into 2 prime numbers, which is 5 times 2. Okay, so I'm going to rewrite my equation, but instead of writing 10, I'm going to write it in factored form. I'm going to write it as 5 times 2. Okay, so 3x plus 6 over 5 times 2. And then the rest of the equation, those denominators are already prime numbers. So I'm just going to rewrite the rest of my equation. Okay. So now let's find our LCD. So to find the LCD, I look for any common factor. So it doesn't have to be a factor that all 4 denominators have in common. It just has to be anything that at least 2 of the denominators have in common. So one of the common factors in the denominators, these 3 fractions all have a 5. So rather than using all 3 5s, 5 times 5 times 5, I only have to use it 1 time. So that way we're going to get the least common denominator. Okay, and then these 2 fractions have a 2 in common. So rather than having to use a 2 and another 2, I only have to use the 2 1 time in my common denominator. Now, if there were other factors that weren't common, I'd have to include those as well. But in this case, that's all we have. We have a 5 and we have a 2. So my common denominator is 5 times 2. You could write it as 10, but I'm going to leave it in factored form because it helps us to know, it helps us to get rid of our denominators when we leave this in factored form, because it helps us to see what's going to divide out. Okay, so once we know our LCD is 5 times 2, I need to multiply everything by this LCD. So I'm going to multiply all the terms by 5 and 2. Okay, so when I'm multiplying by 5 and 2, when I'm multiplying by the LCD, I'm just multiplying in the numerator. So I'm multiplying this term times 5 times 2. I'm multiplying this term times 5 times 2. I'm multiplying this term times 5 times 2. And I'm multiplying this term times 5 times 2. So I always write it out because then I can very clearly see what's going to divide out. All right, so we're going to multiply everything by the LCD. So we found the LCD was 5 times 2, and then I'm multiplying everything by the 5 and the 2. So the reason we did that is to get rid of the fractions. So on this first term here, notice that the 5 that I multiplied by is going to divide out with the 5 that was in the denominator. So the 5s are going to divide out. And then the 2 that I multiply by is going to divide out with the 2 in the denominator. So both factors, or both terms in the denominator, both factors in the denominator divided out. And so all we're left with now is 3x plus 6. Okay, and there's no more fraction on that term. Then I've got the minus sign. Now right here from the second term, the factor that's going to divide out is the 2. The 2 that I multiply by is going to divide with the 2 in the denominator. So we're left with 1x times 5. Rather than writing it like that, I'm just going to write it as 5x. 1 times x times 5. Okay, again, no more fractions. Then we've got our equal sign. All right, from this fraction here, the 5s are going to divide out. The 5 I multiplied by and the 5 I divided by. Now notice this, I do have this 2 and this 2. They don't divide out though, because we only can divide out if we have 1 in the numerator and 1 in the denominator. Here, these are all in the numerator. 2 times x times 2. I would just write that as 4x. And then I got a plus sign. And on the last term here, the only factor that divides out is the 5. The 5 divides out, and we're left with 33 times 2, which is 66. Okay. Now you'll notice once we multiply by the LCD, now we don't have any more fractions, and now we just have a linear equation. So now we can solve like we did on example 1. To solve this linear equation, this is what I have so far, 3x plus 6 minus 5x equals 4x plus 66. Remember, we have to simplify each side separately. So the left side here, I can combine like terms. So that will give me a negative 2x plus 6 on the left. All I did was combine a positive 3x and a negative 5x. On the right, there are no like terms, so I just have 4x plus 66. And now I have variables on both sides of the equal sign. So I want to get all the x's on one side and all the numbers on the other. It doesn't matter, again, which side you move them to. I'm going to move the x's to the left, which means on the left, I'll keep the negative 2x where it is because I want to keep the x's on left. And I got to get rid of plus 6, so I need to subtract 6. And it's an equation, so whatever we do to one side, we have to do to the other. Okay, so I'm subtracting 6 from both sides. So on the left, that means the plus 6 and the minus 6 add up to 0, and we're just left with negative 2x. On the right, now I have 4x plus 60. I just combined the 60 and the minus 6. Then we said on the right side, we only want numbers. So I'm going to keep the 60 where it is, which means I have to get rid of 4x. So to get rid of 4x, I'm going to subtract 4x. So I am going to subtract 4x from both sides. Now on the left side, negative 2x minus 4x is negative 6x. We have negative 6x equals, on the right side, the negative 4x and the 4x add up to 0, so we're just left with 60. Okay, and then lastly, I'm kind of running out of room here. I still don't have the x isolated. I got to get rid of the negative 6 that's in front of the x. So now I just need to divide by the negative 6. That makes the negative 6 divide out, and we're left with x equals, on the right side, 60 divided by negative 6 is negative 10. All right, so we get x equals negative 10, our answer on that one. Okay, like before, we can plug in the negative 10 for the x's and see if it works. It would just take a lot longer to try to do that on this type of problem. But we can always check our answer by plugging in. Okay. So we're gonna pause there in the notes again and do some more practice problems with the fractions, with equations that have fractions in them. So on our next practice problem, let me find one. Okay, not that one, this one. I want you to solve this equation, 3x over 2 minus 5 over 6 equals 2x over 5 plus 1 over 3. So the first thing I want you to do is try to find the LCD. I'm going to give you just a minute to try to find the LCD, and then we are going to go over it just to make sure we know how, but I do want to give you a chance to try. What I want you to look for when you're trying to find the LCD we have to have all the factors. So look at if any of the denominators, right now our denominators are 2, 6, 5, and 3. See if any of those can factor more. The only one that can is the 6. We can write that in smaller factors. And then once we have that written in prime factors, look for common factors as well as any other factors. So I'm going to give you a minute to try to find the LCD. If you think you know it, you can type it in the chat to me or to everyone. If you don't know how to do it, just hang tight for a minute and we'll go over it in 1 minute. Okay. I am going to go through the process of finding the LCD with you. I didn't get any responses back, so I'm guessing maybe we don't know how to find the LCD. As I said, we want to look at the denominators and factor any that we can. So in this case, the only denominator that can factor more is the 6. Right, so I'm going to write this, instead of writing 6, I can write it as 3 times 2. Okay, so I'm going to rewrite that fraction as 5 over 3 times 2. All the other fractions are staying the same because they're already prime. So 3x over 2 minus 5 over 3 times 2 equals 2x over 5 plus 1 over 3. All right, so if I'm finding my LCD, I'm looking first for common factors. So I see that these two fractions have a 2 in common. That means I only have to include the 2 one time. Then these two fractions have a 3 in common. So I have to include the 3 one time. And then there's this other factor of 5. I have to include that as well. So I'm including the 5 as well. So instead of using all the factors, I only have to use the 2 once and the 3 once, and then I also have to include the 5. So I have my LCD is 2 times 3 times 5, or in other words, that would be 30. Now that you know the LCD, now I want you to try to finish solving this problem. So now you're going to multiply everything by the LCD. So multiply all the fractions by 2 times 3 times 5 to get rid of the fractions, and then solve from there. So I'm going to give you another minute or so, probably a little bit longer to solve that. And then once you have an answer, type it to me in the chat. All right, if you think you have an answer, type it to me. It can be privately if you want. Good, I'm seeing lots of correct answers starting to come in. Okay. So I saw a lot of good answers. I didn't get to respond to everybody as you were working. The solution is x equals 35 over 33. And we would want to just leave it as a fraction rather than trying to get a decimal or anything. So let's go ahead and go through this. We already found the LCD, and it seemed like once we knew the LCD, a lot of you were able to solve the problem. So now I need to multiply everything by the LCD. So I'm multiplying this fraction by 2 times 3 times 5, this fraction by 2 times 3 times 5, this one by 2 times 3 times 5, and this one by 2 times 3 times 5. So I'm multiplying everything by the LCD. And I have it in factored form because then I can see what is going to divide out. So from the first fraction, the 2 that I multiplied by is going to divide out with the 2 in the denominator. So we're left with 3x times 3 times 5, which is 45x. Then I have my minus sign right here on this fraction. The 2 and the 3 both divide out. The 2 and 3 that I multiplied by divide out with the 2 and 3 in the denominator. And I'm left with 5 times 5. Or in other words, that'd be 25. So on the left side, we have 45x minus 25. Then we've got the equal sign. On the other side of the equal sign, right, on this fraction, the 5 divides out, and we're left with 2x times 2 times 3, which is 12x plus, on this fraction, only the 3 divides out, and we're left with 1 times 2 times 5, which is 10. Okay, so after we get rid of the fractions, this is what we're left with, and this is just now a linear equation. And we can solve from here. So with the linear equation, we want to get the x's on one side and the numbers on the other because we're trying to isolate the x. If I'm trying to get the x's on the left side, I'm going to add 25 to both sides. And that will get rid of this minus 25 here. Now, I'm going to kind of do 2 steps at once, just so to save a little time and space. And some of you probably do this as well. We're trying to get numbers only on the left, on the right. So from the right side, I need to subtract 12x, get rid of this. So I'm going to subtract 12x from both sides. On the right side, that will get rid of that 12x. Okay. So now on the left, I have 45x minus 12x, which would be 33x. On the right side, I have 10 plus 25, so that would be 35. And then to get the x by itself, divide by 33. And so we get x equals 35 over 33. Okay. So that's where our answer is coming from. Once we get rid of the fractions, so once we multiply by the LCD, that should get rid of all the fractions. And then we can just solve the regular linear equation from there. All right. I'm thinking it might be helpful to do another one like this, just based on the answers I was seeing. All right. I'm going to change this one slightly. So 5x over 14 minus 1/2 equals x plus, let's say, x plus 1 over 6. Okay, so the first thing you need to do is find the LCD. I am going to give you a minute to try to find the LCD first. And then you can type just the LCD to me, just so we can check that before you try to do the rest. Okay, so take a minute and find the LCD on that problem. All right, we're gonna check the LCD part. So you can make sure you have the right LCD. So the LCD, the least common denominator, a lot of you who responded have that. The LCD is 2 times 3 times 7. So if you did get this, go ahead and you can keep going and simplify or try to solve the equation. If you did not get 2 times 3 times 7 as your LCD, we'll talk about where that comes from. So this time, and before you solve, one thing to remember is make sure you multiply everything by the LCD. Even this factor or this term, even though it doesn't have any fractions, you still have to multiply everything. Otherwise, it's not equal anymore. So let's talk about where that LCD comes from. Our denominators are 14, 2, and 6. We want to try to factor the denominators. The 14 can factor more to 2 times 7. The 2 does not factor more. And the 6 factors more to 2 times 3. So I rewrote the 14 and the 6 in factored form. Okay, now we can look and try to figure out what the common denominator is. The only common factor we see is a 2. All 3 fractions have a 2 in common, so I only have to include the 2 just one time. So there's only 1, 2 in my common denominator because they have that in common. Okay, then I also have to include any other factors. I have to include the 7, and then I also have to include the 3. Okay. So that's where our LCD is coming from. I have to include all the factors, 2, 7, and 3, but if any of them are in common, I only have to include it once. So I only have 1, 2, and then a 3 and a 7. Okay, so now that we know the LCD, continue with the problem and see if you can solve. So multiply everything, including the x, by that LCD, by 2 times 3 times 7, and that should get rid of all your fractions. In about 1 more minute, we'll go over this one. All right. So if you did get this, I tried to respond to tell you if you were correct or not, but I think I may have missed some. The answer we should get negative 28 over 27. So again, let's go over this one. We already went over how we got the LCD. So the LCD is 2 times 3 times 7. So I'm going to multiply everything by 2 times 3 times 7. The most common error when there is a term without a fraction is that people forget to multiply that by the LCD as well. So I have to multiply this x by the LCD as well. You have to multiply everything on both sides of the equal sign, otherwise it's no longer equal. So remember, on an equation, whatever you do to one side, you do to the other. Okay, so on this side, the 2's and the 7's divide out, and so we're left with 5x times 3, which is 15x. Then I have a minus sign. On this fraction, the 2 is the only factor that divides out, so I have 1 times 3 times 7, so that'd be minus 21. On this, it's not a fraction, so nothing divides out, so I have to multiply it all together. So x times 2 times 3 times 7, that would be 42x. So that, make sure you multiplied that, otherwise that could explain where your answer went wrong. And then on the last fraction, the 2 and the 3 divide out, and we're just left with 1 times 7, or just 7. All right, so that's what we have now. 15x minus 21 equals 42x plus 7. Now there's no more fractions, and now this is just a linear equation. So we can solve from here. We want to get the numbers on one side and the variables on the other. Doesn't matter which side. I usually just get the x's on the left and the numbers on the right. So on the left side, I'm going to add 21 to both sides, because that's going to get rid of the minus 21 and the positive 21. All right, so then I got 15x equals 42x plus 28. And on the right side now, I want to only have numbers, so I'm going to keep the 28. I want to get rid of the 42. So I have to subtract 42x from both sides. Okay, when I do that, on the left, now I have 15x minus 42x. That gives us negative 27x. On the right, we're left with 28. Okay. Then the last step, divide by negative 27. And we get x equals, it doesn't reduce or divide evenly, so I am going to just leave it as a fraction. If you wrote it 28 over negative 27, just like this, that's fine. A lot of times though, you'll see we put the negative in the front, so negative 28 over 27. Okay. Overall, that looked good. I know these sometimes just take a little bit of practice to get used to. And I know you've seen them in Algebra 2, but it's been a while. So it's always good to see those again. Okay, So with what we've seen so far, both the solving equations without any fractions and then the solving equations with fractions. So just in general on all the kinds we've seen. I'm going to do a camera check. I want you to turn your cameras on and show me from fifths to 5 how you feel so far with the equations. So 0, 2, 3, you might be in the middle. 5 if you feel like you've got all of these. I'm just checking in on everyone. If your camera's not working for some reason, you can send me a message just so I can, make sure you didn't fall asleep. Okay. I think I got everyone. All right. So, and then I think, yep, if your cameras weren't on, I see some responses in the chat. Perfect. All right. We are going to, before we're done, I know this has already been a long day, we're going to do 2 more examples in the notes that are special cases we might see. So we're going to do, like I said, 2 more examples in the notes. So get your notebook or whatever you're taking notes on. And we're going to see a couple special cases. They're not going to have fractions, so they shouldn't take too long. Okay. So far, we've done 2 examples in the notes, 1 and 2 here. And like I said, we're going to do 2 more, number 3 and number 4. So go ahead and write down example 3. -3 times the quantity 2x minus 1 plus 5x equals 3 minus x. -3 times 2x minus 1 plus 5x equals 3 minus x. Okay, so this example does not have any fractions. It is going to be a linear equation. So I just need to just solve like we've been solving. So on the left side, I need to simplify the left side separately first. So on the left side, the first thing I want to do is distribute this -3 to get rid of the parentheses. So that gives us a -6x and a +3. Then we still have this plus 5x right here. So these 2 terms now, so now I have -6x plus 3 plus 5x. I can combine the -6x and the 5x because they're like terms. Since they're on the same side of the equal sign, I'm just combining or simplifying. So that would give me a -x plus. Okay, then I've got my equal sign. My right side here, 3 minus x is already simplified. There's nothing that can combine there. So I'm just going to have 3 minus x. Okay, at this step, some of you might notice that this is starting, it might look a little strange, but we're going to just keep going like we have been. We're trying to isolate the x, so I want to get all the x's on one side of the equal sign and all the numbers on the other. So if I'm trying to get the x's on the left side, I'll keep the -x where it is, and I got to get rid of +3. So I'm going to subtract 3. I'm going to line it up with the number here, this 3. So on the left side, the +3 and the -3 would add up to 0. So we're just left with -x. Now notice on the right side, that also happens. A +3 and a -3 adds up to 0. Usually we don't write the 0 But because remember on this side we want a number, I'm gonna go ahead and write the 0 for now. So this would be 0 minus x. But normally we don't have to write the 0. Now, again, you might notice something from here, but I'm gonna keep going. On this side, we only want the number, so I'm gonna keep the 0 where it is. Then to get the x by itself, I'm going to add x to both sides. Now on the right side, like we were trying to do, the minus x and the plus x add up to 0. But notice what also happens on the left side. We have another minus x and a plus x, which also adds up to 0. So in this case, after we get the x's on one side and the numbers on the other, this is a special case where our variables eliminated. The variables were eliminated and we're left with 0 equals 0. If your variables are eliminated, think to yourself whether you're left with a true statement or not. So ask yourself, is it true that 0 is equal to 0? And yes, that is true. 0 is always equal to 0. So what that means, if you end up with something like this means that the solution is all real numbers. So what that means is any number I plug in for x will work. Now here's a couple places we could have seen that. If we looked at this step here, you might have noticed that the two sides of the equal sign were already equal, even though they were in a different order. We had a negative x plus 3 and then a positive 3 minus x. So the two sides were already equal. Now it does not have to be 0 equals 0. We could have been solving and got something like 3 equals 3, and that would still be a true statement. So you don't have to have one side equal to 0, but if the variables eliminate and you're left with a true statement, that means the answer is all real numbers. Because if I would plug in an x, it would make both sides equal no matter what value that x is. All right, so that's one special case we can see. We got one more example. All right, so go ahead and write down example 4. This is going to be our last example of the day. So write down this example, 10 plus 14x equals 7x minus, or sorry, I'm saying that wrong. 10 plus 14x equals 7 times the quantity 2x minus 5. So write down example 4. 10 plus 14x equals 7 times 2x minus 5. All right, so by looking at this, we don't know that this is a special case. So we're just going to proceed like we normally would. Simplify each side separately. The left side is already as simplified as it can be. So 10 plus 14x equals, on the right side, all I can do to simplify there is distribute the 7. And that's going to give me 14x minus 35. Okay. So again, right here, you may not notice that this is going to be a special case, or some of you might notice why this would be a special case. We'll talk about that in a second. But let's proceed like we normally would. If I'm trying to isolate the x, I want to get the x's on one side and the numbers on the other. So the first thing I'm going to do on the left side, I'm going to keep the 14x where it is, and I'm going to subtract 10. So now on the left side, I just have 14x. On the right side, I have 14x minus 45. Now on the right side, we only want numbers. So that means I have to get rid of the x. I got to get rid of the 14x, so I'm going to subtract 14x. And of course, whatever I do to one side, I do to the other. So now I got rid of the 14x on the right. But notice what happened on the left as well. On the left, I had 14x minus 14x, which gives me a 0. The variable eliminates, and I'm just left with 0. And on the right, I'm left with negative 45. So we have 0 equals negative 45. Now, if your variable eliminates, ask yourself if you're left with a true statement or a false statement. So is 0 equal to negative 45? Definitely not. This is a false statement. So what that means, if you end up with something like this that is never true, that means there is no solution. So on this example, no matter what x value I plugged in, there would be no way to make the two sides of the equal sign the same. So we had 0 equals negative 45, which is never true. That's a false statement, so that means there's no solution. Like I said, you may have noticed earlier on, we had 10 plus 14x, and then we had 14x minus 35 on both sides of the equal sign. The 14x part was the same. So you might have also ended up with 10 equals negative 35. So it doesn't have to have a 0 to be able to tell. There's no way those would be equal to each other. So since 0 is not equal to negative 45 or 10 is not equal to negative 35, depending on what you subtracted, there's no solution on that one. All right, those two don't come up all that often, but I just wanted to make sure we at least saw an example like those, because it's good to know what that means when you have either infinite solutions, which can be any real number, or no solution. Okay,